This tutorial is for 5th grade, Module 5, Lesson 7. In Lesson 7, we're going to use our knowledge of volume to answer word problems. The first problem says Jeff builds rectangular planters. Jeff's first planter is 8 feet long and 2 feet wide. The container is filled with soil to a height of 3 feet in the planter. What is the volume of the soil in the planter? And we're to explain our work using this diagram. The first thing I'm going to do is write a sentence with my answer statement. So the question is, what is the volume of the soil in the planter? So I'll say, the volume of the soil in the planter is blank. Now if I go back to the question, it says that the container is 8 feet long, so I'm going to mark that on my diagram. So it's 8 feet long and it's 2 feet wide. We are not given the height of the planter, but we do know that it is filled up to the 3-foot mark. Again, since we don't know the height, I'm just going to choose a mark to show that that would be considered the 3-foot line. So from the bottom of the planter to this line is 3 feet of soil. To find the volume, we'll just use the same procedure we have been using, taking our length, which is 8 feet, times our width, which is 2 feet, and we'll multiply that by the height of the soil, which is 3 feet. I'm going to combine these first. 2 times 3 is 6, and then I'll take 8 times 6 to get a final answer of 48 cubic feet. That means the volume of the soil in the planter is 48 cubic feet. The next section says Jeff wants to grow tomatoes in 2 large planters. He wants each planter to have a volume of 320 cubic feet, but he wants them to be different. And we're to show 2 different ways Jeff can make these planters. Well, since the volume has to be 320 cubic feet, I know if I take my length times my width times my height, I have to get an answer of 320. So I need 3 numbers, and when I multiply them, I get 320. Well, I know if I multiply 8 times 4, I would get 32. And if I multiply 32 times 10, I would get 320. So I'll show my planter as having a length of 8, a width of 4, and a height of 10. I'll finish drawing that. And I'll label my sides. So the width was 4 feet, the length was 8 feet, and the height is 10 feet. And that would give us a volume of 320 cubic feet. Now I just need to come up with 3 different numbers that I could multiply that would also give me a volume of 320 cubic feet. I'm going to look at the numbers that I used over here and see if I can adjust them to give me some different numbers. I could break my 4 into 2 times 2. That way I could say 8 times 2 times 20 would give me an answer of 420. 2 times 20 is 40. 40 times 8 is 320. So again, I would have a length of 8, this time a width of 2, and a height of 20. So I'll finish drawing this, and then I'll mark my dimensions. So we said we had a length of 8 feet, a width of 2 feet, and a height of 20 feet. And that would give me a volume of 320 cubic feet. So these are 2 examples that would work for the problem. There are several more that would also work. The next section says, after all of his gardening work, Jeff decides he needs a new shed to replace his old one. His current shed is a rectangular prism that measures 6 feet long by 5 feet wide by 8 feet high. He realizes he needs a shed with 480 cubic feet of storage. Will he achieve his goal if he doubles each dimension? Why or why not? Well, first let's look at his current shed. That shed is 6 feet by 5 feet by 8 feet. Let's determine the volume of the current shed. So if I multiply 6 times 5, that's 30. 30 times 8 is 240. So the current shed has 240 cubic feet of space. And again, the question is, if he doubles each of these dimensions, will he get a shed with 480 cubic feet of storage? Well, let's see what happens when we double the dimensions. Now I have 12 feet by 10 feet, I'm doubling each number here, by 16 feet. And we need to multiply those. If I multiply 12 times 10, I get 120. 120 times 16 is actually 1,920 cubic feet. So if he doubles each dimension of the shed, he gets a shed that is this big. So no, he can't just double the dimensions to get a shed that is 480 cubic feet of storage. What he really needs to do is just double one of the dimensions. For example, if we kept the 6 feet the same, but then doubled the 5 feet, that makes it 10 feet, and kept the 8 feet the same, let's see what we get. Well, 6 times 10 is 60. 60 times 8 is 480 cubic feet. So there's the measurement he wants. So if you want to double the volume, you can only double one of the measurements, not all three. The next question says, if he wants to keep the height the same at 8 feet, what could the other dimensions be for him to get a volume of 480 cubic feet? Well, I just showed you the example where he kept the 6 feet and the 8 feet the same and changed the 5 feet to 10 feet. Let's look at another way you could do this. We could also say that if you changed your length to 30 feet and your width to 2 feet, you would still get a volume of 480 because 2 times 30 is 60, 60 times 8 is 480. And then the follow-up question to that is, what is the area of the floor of the shed in part B? Well, to find the area, we would take our length times our width. 30 times 2 would give us an area of 60 square feet. But if you think about this, having a shed that's 2 feet wide probably isn't that practical, especially when it's 30 feet long. If I think back to our other measurements where we took 6 times 10 times 8, this would be a 6 by 10 floor. That would be an area of 60 square feet as well. And that measurement might be a little more realistic. A 6 foot by 10 foot shed might be a little more realistic than a 30 foot by 2 foot shed. But each of those dimensions still work.